we say y is a function of x if and only if every x value corresponds to exactly one y value. Okay, this is often when we replace that y with f of x. So for example, here's a function it says f of x, so this function of x, is equal to 3 times x squared minus 6x plus 3. We can see that our input is here. So if I want to find f of a number, I would put it there. And then the input also goes here for x. And then the output is the value after substituting. I want to graph this function, and the way I'm going to do that is just make a few ordered pairs and then try to connect them with a smooth line. So here again is my input. And then when I do the calculation, I'll get my output. So let's say we want to find what this is for -1. So I would take 3 times -1 squared minus 6 times -1 plus 3, because that's f of -1. This is going to be -1 squared is 1, so 3 times 1 is 3, minus 6 times -1 is plus 6, and then plus 3. This is going to be 12. So that gives me the ordered pair -1, 12 is a part of the graph of this function. What if I put in 0? Well, f of 0 is going to be 3 times 0 squared minus 6 times 0 plus 3. This is 0 minus 0 plus 3, so 3. So the point 0, 3 is going to be on the graph of this function. If I put in 1, f of 1 is 3 times 1 minus 6 times 1 plus 3. 3 minus 6 plus 3 is 0. So 1, 0 is a point on the graph of this function. And finally, let's just do one more. How about 2? F of 2 is 3 times 2 squared minus 6 times 3 plus 3. 2 squared is 4. 3 times 4 is 12 minus 6 times 3, so minus 18. Oh, I'm sorry, 2. Minus 6 times 2, 6 times 2 is 12, and then plus 3. This should be 3. So 2, 3 is a point on our graph. Okay, so let's graph this function. Here I've got a little coordinate axes. So we had the point -1, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We had the point 0, 3, 2, 3. We had the point 1, 0. And we had the point 2, 3. So this, assuming I can draw my line decently, would be the graph of our function. So this is f of x equals 3x squared minus 6x plus 3. In a function, or for a function, the set of all inputs is called the domain. Here we can see from our graph, the domain is all real numbers. That's because I can put anything I want into this for x and get something out. I'm not doing any word division, there aren't any roots or anything, so the domain of this function is everything I could put in for x. We have a name for the set of all outputs. A set of all outputs is called the range. Now, looking at our graph, we can see that the only outputs I'm going to get here, the only y values would be those that are 0, because we got down to 0, and bigger. So the range for this problem is all numbers greater than or equal to 0.